Bohr diagrams. Bohr diagrams show how many electrons appear in each electron shell around an atom. For the first 20 elements, the maximum number of electrons in the first shell is 2, in the second shell is 8, and in the third shell is 8. This Bohr diagram of aluminum has 2 electrons in the first shell, 8 electrons in the second shell, but only 3 electrons in the third shell. The third outermost shell is not full. Electrons in the outermost shell are called valence electrons, and the outermost shell itself is called the valence shell. Boron has 2 electrons in its outermost shell, and since the second shell can hold 8 electrons, this shell, the outermost shell of boron, is not full. Silicon has 4 valence electrons in its outermost shell, and antimony has 5 electrons in its outermost shell. Which element is this? It has an atomic number of 18, which should mean that it has 18 electrons. If we count them up, that's so. First shell, there are 2. Second shell, there are 8. And in the third shell, there are also 8. Therefore, there are 18 electrons. It has 3 electron shells, so you would find it in period 3. And it has 8 electrons in its outer shell, which puts it right here. And it means that this element is argon. Patterns of electron arrangement in periods and groups. There's a maximum of 2 electrons in the first shell, 8 in the second shell, and 8 in the third shell. Notice that the only elements with a full outer shell are noble gases. They are very stable. All atoms are unstable unless they have 8 electrons in their outermost shell. So they attempt to gain or lose electrons to have a full outer shell. The arrangement of 8 electrons in the outermost shell is called a stable octet. Atoms tend to gain, lose, or share one or more of their valence electrons to achieve a filled outer electron shell. Forming ionic compounds. Ionic bonds form when metals lend electrons to nonmetals. It's important to know and understand Bohr models so that you can understand this type of bonding. Ionic bonds form when metals lend electrons to nonmetals. When 2 atoms get close together, their valence electrons interact. If the valence electrons can combine to form a low-energy bond, a compound is formed. Each atom in the compound attempts to have the same stable number of valence electrons as the nearest noble gas. Sodium is unstable. It needs 8 electrons in its outer shell. It has 1. Chlorine is also unstable. It also needs 8 electrons in its outer shell, and it has 7 out of 8. If we look closely, we'll see that sodium is nowhere near having 8 electrons in its outer shell, and it's unlikely that it's going to gain 7 more electrons. So the easiest thing for it to do is to lose an electron from its outer shell, and therefore its outer shell becomes the second shell, which is already filled with 8 electrons. If it loses its electron to chlorine, chlorine will also have a stable octet because it will gain 1 more electron, bringing the number of electrons in its outer shell to 8. So they'll both end up with 8 electrons in their outer shell. It's just that with sodium, the outer shell is now the second shell. With chlorine, the outer shell is the third shell, and it's gained an electron from sodium. The end result is that sodium ends up with 1 less negative charge than positive charge, because if you remember, the nucleus has in it protons or positive charges. Sodium has the same number of protons as electrons, just like all neutral atoms. But if it loses this electron to chlorine, it's going to have 1 more positive charge than negative charge, and this gives it a net positive charge. Chlorine, on the other hand, is going to gain an extra negative charge. This means it's going to have one more negative charge than it has positive charges in its nucleus. This gives it a net negative charge. Both of these result in stable ions. And when a positive ion is near a negative ion, they actually attract each other and form what is called an ionic bond. So sodium and chlorine are ionically bonded. Ionic bonding takes place between a metal, in this case sodium, and a nonmetal, in this case chlorine. Ionic bonds form when metals lose electrons and nonmetals gain electrons. Electrons are transferred. Forming covalent compounds. Covalent bonds form when two nonmetals share electrons. Covalent bonds form when two nonmetals share electrons. This occurs because the electrons are shared between atoms so that each atom thinks it has a full outer shell. In this case, oxygen has 6 valence electrons, but it needs to have 2 more to form a stable octet. Hydrogen has 1 electron shown in green. This hydrogen here has 1 electron shown in green, but in order to have a full shell, it needs 2 electrons. You should remember that the first shell of each one of these atoms is full with only 2 electrons. So what hydrogen and oxygen end up doing is they share their electrons, and oxygen will share 1 electron with each hydrogen atom so that each hydrogen atom believes it has 2 electrons. And because hydrogen is sharing its lone electron, each one of these hydrogen atoms is sharing its lone electron with oxygen, the oxygen believes it has 8 electrons in its outermost shell. This forms a very strong bond called a covalent bond. Here are some examples of covalent compounds. Water made of hydrogen and oxygen, ammonia made of nitrogen and hydrogen, carbon made of carbon and oxygen, and methane made of carbon and hydrogen. Watch the animation that compares ionic and covalent bonding. It takes about 2 minutes. Here are some testers for you. Covalent or ionic. Lithium combines with oxygen, and electrons are transferred from the cation to the anion, and the result is lithium oxide. This is ionic. Electrons are being transferred from the metal to the nonmetal. Covalent or ionic. Hydrogen plus fluorine gives us some shared electrons, and the result is hydrogen fluoride. The electrons are shared. This is a covalent bond. Electrons are being shared between 2 nonmetals. Here are some exercises to help you to understand these concepts a little bit better. Of interest as well, just how small is an atom? It's kind of a neat little video. You probably enjoy it.